let us revisit the program we developed last time, where we have drawn the temperature of starting temperature and ending. We give starting temperature and ending temperature, and then it draws a table. So let me just show you how it was working before. Maybe a little bit more, 10 to 15, and then we just say, and then we get it. That's fine. Then if I try 100 to 15, that still works, except it only gives you the 100, right? Because it's going to not. I mean, 100 to 15 doesn't make sense. So I don't think we need to deliberate that as to why that is the case. So we should actually check to make sure that this actually does not happen. And I have the program right here. So as soon as so let's go through the program here. So what we have is, first of all, we get the table where we are going to actually draw the data. This is a continuation of previous activities, so I'm not going to spend too much time on this. Then we clean up that particular table right here. Then we insert the first row, that's row 0. Then insert 2 columns, column 1, so that's 0, and column 2, which has the index 1. We set the first column to be Celsius. We set the temperature to be Fahrenheit, the second column to be Fahrenheit, and then we get the value of the field called start, and we also get the value of a field called end, and then we just go from start to end, the end right here, and then we just bump up by so our variable C starts at S and then goes up to E, and we just keep on bumping it up by 1. Now this has been working, so why not just continue with that? All we need to do is add one little thing here. As soon as we get the values, I'm going to just say, if S is less than E, and I'm going to have open and close braces. That does make sense. We will actually have 2 statements in here anyway. And then I'm going to say alert. I'm going to just make sure I don't have, I'm not putting tabs in there. I want to start must be less than end. We can have a little bit more meaningful statement if we wanted. And alert will just pop up a window, and then it will say whatever it is going to say, and then we don't want to continue with this. We just return, and that's it. Bye-bye, right? Let's see if this works. I'm going to save this one, and I'm going to go back to my app. I have to refresh, of course, because I have changed it, and then let me just try the same 115. Well, actually, probably it might be a better idea to make sure that it actually still works for the correct values, and it doesn't because I put the wrong, and I'm sure when I was doing that, you were saying as you're watching that I do have a wrong condition. That should be greater than. So let's do that, and then go back, and let me refresh this, and then type that 10 and the 15. I should not get an error message. And that's all good. So then we should make sure that now it's time to test, right? So I'll try 15 and 10 and see what happens. And then draw the table, and that works. Well, we should never really completely trust these things. So let me try something else. Let's say go from 100 to 10, right? And maybe 100 to 20. And actually, it did not work. Our error checking did not work. 100 is greater than 20, but it still did not work. So obviously, we are doing something wrong. I'll give you a little bit of time to think about it while I also think about it. And then we will see what is going on here. 100 cannot be greater than, so 100 cannot be less than 20. 100 is greater than 20, and our condition is right. So and it did work for 10 and 15. So what gives? And what gives is the comparison. So these values that we have, so let me just go back to our program. The values that we have are actually considered to be strings, right? By default, they're considered to be strings. Even though we had set that particular element to be number, it's not doing that. It's just retrieving them as strings when we say value. So actually what we want to do is we want to convert them to numbers. There is a method for strings called parseFloat, and this is where JavaScript is not truly object-oriented, because we don't have, we are not using any object per se. We're just calling a function. So we cannot really call this a method. It's more of a function, the traditional function that we use in C, C++, Fortran, and wherever. Well, I should not talk too much. We have to make sure that this is working before we can start celebrating. So I'm going to refresh this, and I'm going to now say, well, first, as usual, we should test it. 10, 15, does it draw a table? It does. Let's try 17, 15, and see if it draws table. It doesn't, because the values are not good. Let's see if it works now for, what was the thing that I was using before, 120, right? Let's see if it's working for that. And draw table, and now we can see that it does actually now does the conversion, and it's all good now. Okay, so we learned a little bit of new concept here of parseFloat, which allowed us to actually change those strings into numbers. Otherwise, our comparison would not have worked. So we have to be careful when we do these kind of things. Don't be like me and make mistakes, the kind of mistakes that I make. In the next video, we will actually we will also have additional validation where we will use event handlers, and both of them would be important for your question in the midterm.